here we go, on the 20 amino acids. Now, let me make sure that that is running fine. Yeah, it looks like it is. Good, good. So, in my biochemistry class, a big thing with amino acids is that we have to memorize specifically the classes. And so there are 4 different classes. We have the nonpolar amino acids. We have the polar amino acids. This can be broken down, but here I'll make sure I mark them as uncharged. Keep that in mind. Then we have acids. Then we have bases. Now these two are also polar, but they are charged. So that's something to know. The polar amino acids, when I'm saying polar, I mean uncharged here. So but I will mark them as uncharged polar. And then for the acids and bases, I will mark them respectively as acids and bases. So to start, I'll start with the nonpolar amino acids. It's a terrible line. There we go. Start with the nonpolar amino acids. Now, I've seen different acronyms to help memorize them, and I don't like any of them. Disliked all of them that I found online. So I created my own, and this is just me, but what I found helps me the most is just relating them to something. And in the acronym, I was able to make the acronym flip my ATV. Pretty easy to remember. Makes sense. It's not related to amino acids at all, or any biochemistry for that matter, but I like it. And so you're gonna have to bear with me now. You're gonna have to bear with me here. So F is gonna be phenylalanine. L is gonna be leucine. I is gonna be isoleucine. P is gonna be proline. And then we're gonna go to the next word. M is gonna be methionine. Y, a little weird, but it's gonna be glycine. And we'll get more into that later. I think it works with glycine because glycine's also weird, in my opinion at least. And then next word, ATV. So A, go with alanine. T, tryptophan. Last one, V, is valine or valine. And these are our non-polar amino acids. So I'm going to scroll so it's at the top. There we go. All right, so I'm going to leave that. I'm going to leave that on the top there, and then I'm going to start drawing these, and then explaining how I remember these. First one, phenylalanine. So you're going to want to draw your base structure for your amino acid. There you go. I'm actually gonna. It's okay. You can pause and see that. I'm gonna try to leave as much up there as I can. So phenylalanine, you have your base amino acid structure, which will be with every amino acid that we're covering today. So what's gonna happen here is we're gonna have. So something to know actually right now with what I've drawn here. This right here. That amino acid would actually be glycine right now, because right here there's an unseen hydrogen right there, which makes this glycine. But that's just something to note. Hello, there it goes. And then if I were to draw, and then another thing to note is that if I were to draw a line there, so that means there is a methyl group there. That would be alanine. That would be alanine. And the reason why that's important to note in the beginning is because every amino acid will be built off of an alanine, meaning that it's going to start with this carbon there. That carbon is integral for building the other amino acid structures. So I can show this in phenylalanine. So I draw a line there, alanine, but then I gotta draw another line, and it's actually there's gonna be a ring structure here. This is a phenyl group. We're gonna finish it off. There we go. A little messy, but you get the point. So, well, this is actually a benzyl group, but it is, I see it as a phenyl add-on, and this is non-polar. That's all it is. You look for the one ring. You look for that phenyl. There it is. Boom. That's phenylalanine done. Pretty easy to see with the one ring. Next, I'm going to scroll. I'm sorry. Next is leucine. Get that base here. And I think I'll draw it a couple times. And then I'm going to copy and paste it. So again, we're going to start with that alanine. There it is. And then we're going to branch out here. And up there, down there. Because we have we have an isobutyl group. Right there. Isobutyl. And then the way I think of this, to memorize this when I see the skeletal structure, is I'm thinking of connecting the L. Because it kind of looks like an L. I mean, if you turn your head a little bit, that isobutyl, it kind of looks like an L. That's how I remember that. Next is isoleucine. Here, you do your alanine there. And then here it's different. We have one sticking out there. I have one here. It goes like that. So it's kind of like, so you can think of the connecting the L from back up here in leucine. It's just that we shifted it over. This is a different configuration of leucine, as you can tell by the prefix. So what this actually is, this is a sec-butyl group. And I remember it by seeing that there is an I on L. Because you have this kind of looks like an I there. It kind of looks like it's stacked next to the L. Or just recognize that that would be a sec-butyl group. Or if it was flipped, that's sec-butyl. And then another, if I were to draw this as a dash wedge. So with this sec-butyl group here, that methyl there is facing away from you as it's on the dash, and that would make up the sec-butyl group of that isoleucine. Next is proline. So Now this base structure I actually have to write out. So I'll start with the normal one. I'll go back and change it. Because this one, terrible oxygen. I apologize. For this one, it is slightly different. So you are technically starting with that alanine, but here you actually are creating a ring. And you can imagine it goes back and connects back to that nitrogen. But because it's connecting to that, it's going to change here. So it is no longer NH3 on the end. It's now an NH2. Put that plus back. Oh, goodness, I can't. Right, put that plus back there. There we go. And the way I remember this is that it kind of looks like a P. Looks like a long P. If it were maybe rotated and then flipped, because I can't rotate it perfectly like that. But you understand, if I were to rotate that and then flip it, that's what that would look like. So in this, or just memorize, it looks like it's like a P ring with the carbon chain. All right, next is methionine. Now this is quite an important one to know, especially working into DNA, recognizing that AUG, very important. That's not for now. So actually, I'm just gonna go over here and copy this because I want to be lazy. Nothing wrong with that. Sometimes. So I have this methionine here, and so I'm going to say I can start with that alanine, but I'm just going to angle it a little bit. So I'm going to have go here, bam, bam, and I'm going to S there, and bam. Extra branch. This is actually an SH here. You don't have to write it because I mean it's just known that it's bonded there, but I think it's good to have it. I think it's good to have it there. And then you have this methyl coming off of it on the end, which is important. So I think of this one, so there's only 2 amino acids that contain sulfur. It's methionine and cysteine. And the main difference is that this one actually has a sulfur branch. It has that methyl on the end of that sulfur, and which cysteine does not. Cysteine does not. So that's how I memorize that one. All right. And then here we go. Talked about this one a little bit. Glycine, our Y. So this one, I could say I'm done drawing that, but if I really was going to nitpick, there we go. That's glycine. Simple as that. All right. And then next is, I believe, alanine. I'm gonna paste a little template there, and then you just have a line there. Boom, done. Or you can write the CH3 in there, however you like. Next is tryptophan. So here, I'm gonna get my template out. Then we're gonna start with an alanine. It's gonna come out like that, and then this is interesting. This is interesting. So we're gonna have a ring here. Apologize for my art skills. I'm gonna redraw that one. Straighten that out. Oh wow, that's terrible. I'm gonna redo that actually. So straight line there. I want this to kind of go out like that, and then come in like that. There we go. That's better. NH there, and I'm gonna have ring here. It's also bad. Wow, I can't draw today. Whew. There we go. That's still not good, but it's better. Boom. That is your tryptophan. It is what this is here. This structure right here. That is a bicyclo ring. It is the only amino acid with a bicyclo ring here. I'll write it down. Bicyclo ring. Only amino acid with a bicyclo ring. That's how I memorize it. The way some other people memorize this one is that there's apparently a W that can be seen in the ring. To be frank, I don't understand this one. I don't see the W. But if you do, then that's great. You can use that to memorize that one. Lastly, for the nonpolars is valine or valine, however you like to say it. So this one we start with an alanine, then it actually just comes off like that. And best way I memorize this one is that looking at that group coming off of the alanine. So this is actually an isopropyl group. It looks like a V, an upside down V. So this is an isopropyl. Whoa, can't spell. Isopropyl. It kind of looks like an upside down V. It's very interesting. Now that was our last non-polar one. Now next group are our polar amino acids. So the acronym I use for this is STAC GT. Pretty easy to remember, I think. Going again to kind of vehicles for the acronyms. And so what we have here is, as we have serine, T, threonine, A, asparagine, C, cysteine. Then you go to the next one, glutamine, and the last one, tyrosine. I'll put that right there. Beautiful. Now we're going to start from the top. Serine. Let me make sure I have my cards ready so I can look at this. There we go. Serine. Get these other cards ready. There we go. All right. So for this one, paste that template. Yes. So we're going to have that alanine coming off, and then we're going to branch it off, and then boom, hydroxyl. Easy. That's all it is to it. This is an uncharged polar. Memorize that. Next. Where is the card? There it is. Threonine. Template. An alanine here, and then that looks familiar. What's the difference between this and the valine? We have a hydroxyl there. Because this one is classified as uncharged polar. So, and that's because of this hydroxyl group here. That's what's changing the polarities of these amino acids. So, and then here is a methyl, but you don't have to mark that. It's marked with that branch there. And a good way to memorize this is when you're looking at it, you can memorize it as valine with a hydroxyl, or you can think of it as three groups, three anine, three groups. I have one, two, and then I guess you can think of it as three here. Yeah, three here. So you have three there. It's a way to think about it. That's how I memorize it. Three groups for three anine. And this is also uncharged polar. I'm just going to say UP. Next, we have asparagine. Give me a template. Boom. Alanine. Branch it. We have a carbon, an amino, and a carbonyl here. So this is actually, what this is actually an amide. I'm going to write that down. Bam. This is important. There's only 2 amino acids with amides. Or amides. I have no clue how to pronounce it, to be honest with you. This is uncharged polar, and this is directly associated with aspartic acid. Because if I were to take this amino group and exchange it for a hydroxyl, then this would be aspartic acid. Very interesting. But best way I memorize this is by counting the carbons. So I have 1, 2. I memorize how I have 2 branched carbons. I'll write that down. 2 branched carbons. That's important to know, because when we get to the other acid, that'll be good to know. Next is cysteine. Let me get my template. Alanine, branch, and then your sulfhydryl group. Now, if I were to add a branch to this sulfhydryl group here, it could easily be mistaken for methionine, but it is not, because you need an extra carbon on that chain there. So we're just going to get rid of that. So I'm going to mark that as the sulfhydryl. Now, something to note is that this one varies in polarity, but we do categorize it under the uncharged polar. We do categorize it under that. Last two for the polar. Oops, I'm a step ahead. This one is glutamine. There we go, now I can do it. So we're gonna have our alanine branch come out, and then another branch for that oxygen, and amino for an amide. I don't know. This is uncharged polar, and count the carbons, 1, 2, 3. That's what differs. That's what makes it differ from asparagine. So we have 3 branched carbons. You can see differences here. And the last one for our polar is tyrosine. Let's get our template. We have alanine that branches out to this fun ring. And you go, oh, that looks awfully familiar. That's phenylalanine. But no, we're not done. Branch there, hydroxyl group. That makes this uncharged polar. And The way I memorize this one is by imagining, looking at this, it looks like a tire. You can kind of think it looks like a tire on a tire swing. You have like the rope, and it comes down to the little tire, and maybe the rope extends a little bit, and then you have a hydroxyl there. That's how I memorize it. You can memorize it as a phenylalanine with a hydroxyl group, whatever works for you. But I'll write this as a tire ring. That's what I'm calling it here. All right, home stretch. Next are our acids. So the acronym I use for our acids is AGA. Now this one I did not come up with. I got this one from online, and it is, the way they wrote it is that acids give away, in the sense of they give away protons, or proton donors. And so what this really stands for, so this one, acids, kind of labels that, and then G, glutamic acid, A, aspartic acid. Not a lot to memorize. It's pretty simple. It's only two. So for the first one, glutamic acid. Get our template here. It's a little close there. Boom. Your alanine branch. Oops, oops. There we go. Now, and now if I were to draw the NH2, that would be glutamine, but this is an acid. So we need that carboxylic acid there. So 1, 2, 3 carbon branch. So 3 carbon branch. That makes it glutamic. Aspartic acid. Get our template. Alanine branch. And then you can draw the carbon here. That would make it work, but here, I'll just keep it like the one above. Oxygen there. Boom. Another carboxyl group. And then here we have 1, 2 carbon branch. That's how those two differ. They differ in both their uncharged polar states, and they also differ in their acidic states. Now, last one is bases. The acronym for this is, I remember it as BALL, with an H on the end. And this is bases adopt lonely hydrogens. So what it's going to be, so B is bases, like our label. Then A is arginine. L is lysine. And H is histidine. Scroll down, scroll. Oh, it won't let me scroll. Oh, okay. So the first one is arginine. Paste our template there. And then we are going to branch this out like that. Have this come down. NH2. Oh, let me rewrite that. It's onto a carbon. Amino there. This is double bonded. Another amino here. So here we have 1, 2, 3 amino groups. There's no other amino acid like that. And the best way I remember this one is that I think that it looks kind of like an anchor. This whole thing kind of looks like an anchor. Like you have the tether there, and then oh gosh, I don't know. We have an anchor that doesn't look like an anchor, but you have this heavy thing connected to your tether, and then acts as an anchor. Is it an anchor like that? I don't remember what they look like, but or if you want to think what could be an anchor, it's related to arginine, kind of like a pirate. Something to think about. So that's why I call this an anchor group, that arginine. Next, our ball acronym is lysine. Get that template. And we're gonna come out here, bam, boom, boom, boom. At the very end, we have an NH3 plus there. Now, this thing on the end is what makes it basic. This is, oh, get rid of that. This is a protonated amino group. And there's also really no other amino acid that looks like that has a 1, 2, 3, 4 carbon chain going to a protonated amino group. But if you need a special way to memorize this, I kind of think of it as amino from line. You can think of lysine as linear. Linear is kind of a good one because of that long chain going to that amino group. Now, our last one, our very last one, we're on the very last one, is histidine. So we're going to get our template here. We're going to have an alanine come out here. We're going to have a branch. We're going to go boom. This one takes a bit to draw. There we go. Now this looks interesting, but there are easy ways to remember this. It kind of looks like that. It kind of looks like a house. Oh, that was a terrible house. There you go. Little windows. It kind of looks like a house. If it had aminos there. But this is like an amino ring. That's how I remember it. Remember it as house. And that is all the amino acids. For an overview, we have nonpolar was flip my ATV. To memorize what that stands for. For polar, uncharged polar, we have stack GT. Memorize what that means. For acids, we have aga. And for bases, we have ball with an H. Memorize those acronyms, memorize what they stand for, what they mean, and I can assure you that that will help you towards any upcoming tests or work that you will have regarding these amino acids. Good luck. Thank you for watching Tablet Teaches. I hope you enjoyed our lesson today. And if you did enjoy it, why not like and subscribe? It's free, and you can always change your mind later. If you're doing that, might as well hit that bell, get any notifications of when we upload. And I hope you have a blessed day. Good luck in your studies.